Hello guys, myself Sunanda. This will be my third video lecture for chemical bonding and molecular structure. The reference is NCERT, you know. Here's something about me. Okay, in this video lecture, we will quickly go through the topics we covered in the second lecture. First is the formal charge. So, formal charge is actually the charge in the atoms, and this doesn't indicate the real charge separation within the molecule. Okay. So, the charge will be the smallest charges for each atom, then we will get the stable structure for the Lewis dot structure. Okay. And then we talked about the coordinate over the dative bond, and we talked about the nature of the electron donor and the electron acceptor. I mean the electron pair donor and the electron pair acceptor. Okay. And how is it different from coordinate, how is it different from covalent bond. Then we talked about the limitation to the octet rule. So, in limitation, the first thing we knew is the elements that have valency less than 4 will not have the complete octet, but still they exist. Then similarly, odd electron molecules also exist without having a complete octet for the central atom or for some atoms present in the molecules. Then we talked about the expanded octet, where we said the availability of the 3d orbital will allow the elements actually to attain more electrons than octet. Then we talked about the noble gas, which can also make compounds with more electronegative atoms like fluorine, oxygen. And then finally we said that the shape and the relative stability of the molecule cannot be concluded or cannot be explained using the octet rule. Okay. Then we talked about the ionic or the electrovalent bond, and here we said that the ions take part are positive and negative, which we call the cation and anion respectively, and they are formed by releasing and gaining electron, gaining one more electron. Okay. So, the ionic compound formation actually depend on the ease of formation of the positive or negative charge, and then with the arrangement in the lattice of the crystalline compound. Okay. So, for the formation of the positive charge, ionization enthalpy comes into picture, and for the gain of one electron gain enthalpy comes into picture. Finally, when we get M plus and X minus in the gaseous state, one molecule forms with ionic bond in the solid state. Okay. So, here we will now talk about the energies, which here we have written as enthalpy. So, enthalpy is a form of energy. Okay. Then electron gain enthalpy. So, electron gain enthalpy actually is the amount of energy released when a gas phase atom in its ground state will attain one more electron. Or okay, so it will actually gas phase molecule, suppose X, that will gain one extra electron, and the energy released there will be the electron gain enthalpy, and that can be both exothermic and endothermic. Okay, I mean exothermic or endothermic. Then ionization enthalpy. So, ionization enthalpy is for the cation, I mean when the element loses one electron and form a cation. So, the amount of energy, the minimum amount of energy required to remove the loosely bound electron is known as the ionization enthalpy, and that is always endothermic in nature. Okay. So, then one more term is there known as electron affinity, that is the negative of electron gain enthalpy. Fine. Now, we will know how easily or how the ionic compounds are formed with ease. Okay. So, if we will take a cation with low ionization enthalpy and anion with high electronegativity or electron gain enthalpy, then the ionic compound will be easily formed. And we know that the ionic compound involved positive and negative ion, thus the electrostatic force will come into picture, and thus the Coulombic energy. Here the cations and anions are arranging themselves in the 3 dimension in the crystalline state. Fine. So, we know that now we know that the ionic compounds have electron gain enthalpy and ionization in the energy or enthalpy due to the presence of positive ion and negative ion, right? So, these are the two energies we know. So, experiments confirmed that even if the energies, if we sum, gives a positive value, then also the structure gets stabilized, and that they concluded due to the formation of the crystal and the energy released there, they called as lattice enthalpy. I mean, if we will add electron gain enthalpy and ionization energy, we will get a positive charge, right? If we will get a positive charge, then also the structure is stable, because there will be a release of energy due to the formation of the crystal lattice. Okay, and the main thing I want to say is, we know that when the energy is released to the surrounding, we say that the compound formed will be stable. Okay, so here we are talking about the positive value of energy. That's why we want to know how the structure is getting stabilized even if the summation of the energies involved are positive. So the dominating energy here will be the crystal energy, because the positive and negative energy are just not attracted or arranged by the electrostatic force. They also have one more force that came into picture, which is the one more, I mean to say, energy, which is the lattice energy. Due to their arrangement, I mean, Na and Cl will have a particular distance, will have a particular angle when they will be arranged in the three-dimensional crystal structure. Okay, that's why lattice energy comes into picture. Okay, so here I have taken the values from NCERT. The electron gain enthalpy for Cl is minus 348.7 kilojoule per mole. The ionization enthalpy for Na is 495.8 kilojoule per mole. I added and got 147.1, which is a positive value for energy, and then this is also taken from NCERT only, the enthalpy of lattice. Here the value is minus 788 kilojoule per mole. Okay, so the energy released, if we take the magnitude also, it is higher than the energy absorbed, and as it is having a negative value, it will be what? It will be like the stable compound. Okay, so lattice enthalpy, I mean to say, is the most dominating factor here. If the lattice enthalpy will be less less negative, for example, if we will take that the energy released is minus 100 kilojoule per mole, and the electron and the summation of the ionization enthalpy and electron gain enthalpy are 147.1 kilojoule per mole, then the structure will not be stable. But here, as the value is higher, the structure will be stable. Fine. So in the next video, we will more explain the lattice enthalpy. Okay, and then we will talk about some resonance structures, and then this Causal-Lewis approach we will conclude with the bond polarity. Okay, so if you want any more sections to be explained more clearly, you can comment it. Okay, so till then, thank you.